So we've been working on interpreting graphs, and so when we're looking at graphical representations, just a couple of things we want to examine. One, always look at the graph in the headings to see what you're measuring. So it says this is a function s of t, where t is the time in seconds and s is the speed in meters per second. So again, the title of the graph too was plot of speed versus time. So always take a look at those items when you're starting a graphical analysis. A couple other things that we want to take a look at are the following. What is the scale on the axes? Are they the same or are they different? So for our inputs, t, the time, we can see that we're counting by 0.2 of a second every grid mark that we go. For our outputs, s of t, the speed in meters per second, we can see that we're counting by 2 meters per second every grid mark we go. So it's okay that the intervals are different for your axes. We just want to make sure we know how we're counting. So you might even want to write that on your graph. So we said again the inputs by 0.2 and the outputs by 2. All right, then we want to also know the meaning of each axis. So we said our inputs is time in seconds. The output is the speed in meters per second. You also want to look to see, is your relation continuous or discrete? Continuous means you're using all the in-between values represented from point to point on your graph, or discrete is represents using individual data values on your graph. So again, if we look from left to right, we can see that we're continuous because all the in-between data values are used from point to point. That's going to be very helpful when we start working on writing interval behaviors, domain and range, and so on. Then we're looking for key features. Key features meaning x-intercepts, y-intercepts, any turning points, so local minimas or maximas for your graph. And if we look at our graph here, we can see that we have an x-intercept and a y-intercept. They just happen to be at the same point. So we're going to mark that on our graph. And then we also want to talk about any interval behaviors. We label things with pluses if it's increasing, minuses if it's decreasing, a C or a 0 if it's constant, because those will probably come into play in some questions in the analysis. So again, as we look as x's increase, what are the y's, the outputs doing? They're increasing as well, so we could put a plus mark to show that it's an increasing function. So let's take a look at some of the analysis questions. What is the x-intercept? And explain its meaning in this situation. We said we knew our graph had an x-intercept at 0, 0. What does it mean? Well, it means at time 0, your speed was 0 meters per second. Well, what else does that mean? You're starting from a complete stop of the object that you're studying the speed and time of. What is the domain, and explain its context? Well, the domain is the set of all the inputs. So we want from smallest to largest, minimum to maximum. So we're going to look at the far left of our graph and go along the input axis to see how far we're going to the right. And we said it's continuous. We want all the in-between values. So we're starting here at 0, and as I look, we're still using all the inputs, all the inputs, all the inputs to here, right? This is where the input stops. And we want to figure out where that is in our graph. Again, goes back to scale. We said our scale for the inputs was 0.2. So this would be 5.8, 6.0. So our domain is from 0 to 6 continuously. So we would have a bracket, 0, 6 bracket. What does it mean in context? Well, the speed was studied for 6 seconds. So what's the range, and explain its meaning? So the range, instead of all the output values from lowest to highest, we're going to find the lowest output value. Here's our outputs, and look to see how high we're going. We want to find that highest output, which is here. So again, the value that would be, well, what's our scale? Our scale is 2. So here's 40, 42, 44, 45. So our range would be bracket 0, that's our definite beginning, comma, 45 bracket, because we have a definite end. What's its meaning? Well, it means the speeds measured from 0 to 45 meters per second. Find S of 3 and explain its meaning. So what is this telling us? S of 3. 3 is the input value, so 3 seconds. So if we find 3 seconds, which would be here, let's go to the input. What output do we get? Again, scale of 2, that would be at 12. So S of 3 is equal to 12. What's its meaning? Well, at 3 seconds, the speed is 12 meters per second. Find S of t equals 30. So what is this telling us? Our output is 30. So what input does that happen? So we're going to go to the outputs and find 30, which is here. Scroll over to where it lands on your function. What input does it happen at? 5. So t equals 5. What does it mean? Well, after 5 seconds, the speed is 30 meters per second. Write the interval where the graph is increasing. Well, we said in the beginning that as we looked at the outputs, what were they doing for your function? They were all increasing. The entire graph was part of the increasing interval. That happens from 0 to 6. So the interval that we're using is bracket 0, 6. Let's take a look at another scenario. Here we're looking at the attendance at football games. This is the function a of n, where n is a game number and a is the number of attendees. So familiarize yourself with the graph. Things to look for: the scales on the axis. Are they same or different? We can clearly see that they're different. The inputs has a scale of 1/4, and the outputs has a scale of 250. The meaning of each axis: the inputs, it's the game number. The outputs, the number of attendees. Is this function continuous or discrete? Remember, continuous means you're using all the in-between point values on your graph. Well, we can see that's not happening. We have very specific points, so this would be a discrete function. That means that it's going to have very specific inputs and outputs to be used. If it's discrete, we're going to have an individual list for the domain and the range. Do we have any key features? X-intercepts, Y-intercepts, local maximas or minimas? Yes, we have an X-intercept and a Y-intercept. They happen to be at the same point. And again, interval behaviors, increasing, decreasing. Well, because this is a discrete function, they don't exist. We cannot talk about it that way, so we're not going to be able to answer questions on that. So this is just getting used to the graph and what it tells us. Now let's get to the analysis. What is the y-intercept and explain its meaning? Well, we already said we knew where the y-intercept was at, 0, 0. And what's the meaning? Well, if no games are held, then no people attended. What's the domain and explain its meaning? The domain, again, is a set of all the input values, and we have very specific inputs. And since it's discrete, we have to list those inputs individually. So we have a bracket, 0, 1, 2, 3, 4, 5, 6, 7, 8. What are the meanings? It's saying that 8 games were held. What is the range and explain its meaning? The range is the set of all the output values. And we have very specific outputs, again, because it's a discrete function. So we will list those out individually within our brackets. So our range is 0, 3,000, 4,000, 6,000, 7,000, and 8,000. The meaning? The attendance for the games held were those exact number of attendees. So there was a game that had 0, 3,000, 4,000, 6,000, 7,000, and 8,000 people in attendance. Find A of 6. What is this telling us? 6 represents the input for our function. So if I look to 6, what do we get out? 4,000. So A of 6 is equal to 4,000. Its meaning, Game 6 had 4,000 attendees. Find A of n equals 6,000. Well, what is this telling us? 6,000 is the output. We're looking for the input where that happens. Well, the output of 6,000 happens here at 2. It also happens at 8. So n equals 2 and 8. Explain its context. That means there were 2 games at Game 2 and Game 8 where 6,000 people were in attendance. Now it'll be your time to practice some more graphical analysis when it comes to key features, domain range, increasing, decreasing intervals, and the context explanations based on the scenarios given.